How are you?
Good, good. Sorry, I'm late. I've been going from one thing to another so far, and pretty busy day. So, excuse me. So, how far have you guys gotten on conversation?
Not too far, honestly. We've gotten to during the meeting we haven't gotten to talking at all. Is that what you were?
Yeah, yeah. So I guess I'll lead on it. No problem. So, and hi there, Ron. I just saw that you are joining us there. So good to see you. Thank you for all the recent help, by the way.
Sure, Alan. Thanks for your help. We were doing a great job.
Yeah, I very much appreciate everything, all the referrals you passed on. They were helpful. I think we did the best DIU submission we've ever done. So it was great. We worked every single one of your references into the presentation. So hopefully we'll see how it goes. We'll find out in about 30 days, I guess, is when they get back to us. But it's a really good looking presentation, and I'll have to on the sidelines share with you what we're doing for the drone. It's really, really cool. It's very different than anything we've ever done, and I don't think there's anything quite like it. So it's a really, really amazing transitional. So so Chris, so I had suggested to you to take a look at the Southco stuff on the latches. Southco, of course, is completely inappropriate for a drone, considering that their stuff tends to kind of rattle a bit, and it's usually kind of loosey goosey on the tolerances. But they have a lot of mechanism designs that you can reference. There's a lot of mechanical, different mechanical actions you can look at, and mechanical advantages that you get with each one of them. They're definitely worth a look, and it's a lot of times a place we start when we're trying to envision a new mechanism, whether it be a cam latch or an over the center style, fulcrum type of design, or a push button mechanism. Usually the stuff they have is very clunky and heavy, and it's often made out of steel, or stainless steel or chrome plated steel. But it's there's definitely some good information you can glean from kind of researching all those mechanisms. Because of the wingspan that we're talking about on Eagle Ray, which is pretty significant, even though it's a very light aircraft. You need to get you've got a lot of surface area, a lot of lifting surface, and you're going to get a lot of flex in those wings, and presumably you're going to need to make electrical connections through the wing sections. So there's a couple of topics to cover, I think, which includes maybe three main topics related to how you join those wings. How you align the wings is going to be a factor, because there's several parts, right? You're going to have these 1 meter sections, and then there's you want to key it in a way, obviously, that you can't put it together the wrong way, so it's very intuitive. You also need to have something that kind of draws the wing in, and each section in together in a very aligned fashion. So you want to key it, you want to be able to align it, you want it to be precision, and then you have to make an electrical connections, the third thing. So so for that, I would tell you that pogo pin designs are probably going to be the way to go. You can do basically discrete pin connections as well, where they're rigid pins, and those are really secure. We like them a lot, except for the fact that it can sometimes be difficult to separate the wings. So that those are kind of the really high level things that I'm thinking about. Now I'm going to run while we're on the call, and I'll grab some examples I can physically show you from our facility of just unique mechanisms that we've done to latch things together. Unfortunately, there's a lot of designs that Ron has seen before that are ITAR restricted, or they're restricted for various reasons because of branches of the government we work with. So not all of it can I show you, unfortunately, but I could try to lead you kind of to the right path, and I think, and so the one that comes to mind as far as a latch goes that I think makes a lot of sense is the over the center style latches. And again, I'm going to go grab a prop and I'm going to show you some examples of how that can be done. You can do something that's very flush, very clean, completely custom, and it is going to have to be completely custom. Selecting the right materials are going to be really important. Designing all of the features so that it sits nice and flush and you maintain a good laminar flow over your wing surfaces. All of that's going to be critical, and that's also going to help likely decide the material selection and the manufacturing process for the items. And these are items, by the way, that we could quite possibly help you with the design on here. We'd be more than happy to do that. Especially I owe Ron now for some favors he's done for us. So I'd be happy to help with that, help on the design a little bit, and then possibly fabricating some prototypes for you to just prove it out. That would be no problem for us. We have everything in-house to, go soup to nuts, basically, from design to full production in-house. So I think coming up with something unique, very clean, very light, very minimalist, but is more of a draw latch type of solution, I think is the way for you to go, because that's going to pull the wings together very securely. Think of bullet nose pins, diamond shaped pins in various sizes for the different wing sections, smaller ones for the outer wing sections, a medium one for a middle wing section, and maybe a larger one for the wing root to the fuselage. Or it could be done with tubes. It can be done with carbon fiber tubes potentially, but you want it to be keyed in such a fashion that it's just obvious. There is a way that you could even tie it all together potentially by doing a bungee-like mechanism or a spring-loaded mechanism where you can kind of pull the wings apart and fold them, do things like that, which could be really cool as well. But spatially, it may not work with however you're packaging it. That's something you'll have to debate. And sometimes it's not the most durable method to go with, because unless the wings, being that you're going for such a minimalist, lightweight approach, they're not going to necessarily be as rugged as some of the other things that we've done in the past. So you might not be able to just fold a wing on the other and trust that it's not going to damage one part to the other. So separate sections, they're totally kind of divided up in a pelican case, with foam is likely the way you're going to want to go. And we can help you with all the materials, material selection, composite selection, all of that stuff as well. And I have some ideas for you guys on that for low aerial weight fibers, which is where you're going to probably want to go with this aircraft. In fact, there's a French company, it's right here in the United States, that is one of the kind of preeminent, called Comarat, that is one of the preeminent low aerial weight textile manufacturers, and definitely something you should consider. So does that kind of sum up where you're trying to go with this?
Yeah, that sounds great, actually. I know that one of the big questions I had for you, though, was about the durability of these pieces. Because we're going to be flying the drone in such extreme environments. I'm wondering how they would hold up to the extreme cold and such.
Are you talking about the composites, or are you talking about a latch mechanism? That's the latch mechanism is going to be metallic.
Yeah, more so the latch mechanism and also the electrical disconnects. Would those have to be sealed in some way?
Yeah, you're likely going to want to do O-ring seals, and they could be to deal with the extreme temperature climate, especially on the cold environment. You're doing the snow leopard stuff with this. You're going to want to use materials they're going to be stable down to usually they're some of the really extreme materials that you would consider are rated from between 65 to 70 C or minus 45C to 65 to 70C. That's usually the range that they're capable of. Some of the materials are capable of much higher, as far as the hotter temperatures go. But usually that's what they're tested to, because they're typically used, for electronics, and that's kind of the standard, kind of de facto testing that they do for electronic related items. Many of the materials, like carbon fibers, if you're talking about the extremes with that, that's going to come a lot down to the matrix material. The matrix is generally the weak link in the materials. So depending on whether it ends up being a thermoplastic composite or a thermoset, and what type of thermoset, if it is a thermoset, all of those are going to play a factor. And again, we can help you with the selection on that. You're definitely going to be more on the extreme cold side. That's going to be the issue. Now, carbon itself, as you should know, it has basically a 0 CTE. So there's really nothing you can do short side of an explosion that's going to phase change the carbon. Carbon's carbon, but the matrix is the thing that is the opposite in that realm. That is definitely the weak link. As far as the metallic structures go, what we're envisioning is going to be aluminum and titanium, more than likely, for your latch mechanism. It is it may even be just all titanium, so you'll be fine in the extremes.
Okay, that sounds great. Thank you so much.
No problem. So I can run and grab some things real quick, just kind of give you an idea of some of the mechanisms I'm thinking. Yeah, we could talk about kind of how they work. And if you just give me a minute, and I'll just switch off my camera for a sec, and then I'll be right back with you. Give me one moment. Okay, I'm back, guys. Sorry about that. So just give you an idea of one of the cam latch, or excuse me, one of the over the center latches I was talking about. So you can see how this one works right here. So in an open state, it basically looks like that, and then it draws inward as I pull back on this. So this is a pretty cool design. It's actually something right from Southco, and it has an adjustable screw right here. So you can see how you tension the thing. So you can get it to apply just the right amount of force to a wing, basically spar or faceplate that you might have your connector on. You're going to have a connector panel effectively in one of your spars. And we could show you some connectors in a minute. I'll have to run and grab that. In fact, Stefan, if you could, can you have Chris grab some of the pogo pin examples that we have? Because I'm not exactly sure where those are. The last time I saw him, he had them on his desk. So if you don't mind, grab those, because I want to show those in a minute. So imagine with something like this, this part of it being covered. The tab doesn't need to be as substantial. The whole thing doesn't need to be as substantial. In fact, here's a much smaller variation of the same theme, as you can see. And this doesn't necessarily need to be a screw, but it's a pretty cool feature because, again, you can adjust the length of it on an all thread end of it like that, and then tighten a nut on it to kind of counter tighten it and lock it in place once you find that right setting. We would want to do something very different than this that would be completely covered. So you'd have, an extremely small kind of witness line all the way around it when it's flush on the wing. And we may even curve the top of it. So rather than it be something that's sheet metal as it is now from Southco, we would do something that would just be machined out of a chunk of titanium. And that would likely be the answer. So, if this is something that's going to get a lot of repetitive use, titanium is just a wonderful material. It's one of my favorite materials to work with. A lot of people laugh at me about it because we make a lot of titanium stuff. We even make titanium shoulder bolts. Nobody makes bolts like we do. So I often cannot find fasteners that are of my kind of level of quality. So I just make my own. And that thing's a piece of jewelry, and we do that in one of our machines. So it's everything is achievable in a much cleaner way than you're going to find on Southco. But you might find, if you just kind of peruse their massive database, I mean, they have so many different kinds of latches, you might find something really unique that stands out, and you'll just say, hey, that's really the right idea, but I need to make these tweaks. So another one I'm going to show you is, this is a really wild one that we invented here. And this is a real flush design. Originally, this one was designed for boats. And this is not a very lightweight version, but we have a lightweight version that utilizes titanium and aluminum that are combined together. And the way it works is, you'll see there is a cam latch here. I'm going to flip that up. And what it does is it disengages this draw latch head, and you can see it's basically got an inverted chamfer on it at the very end of it. And you'll notice there is a helix cut into the lever right there. So when I rotate this, it draws that pin in, and it's nice and flush. And we did a version of this where everything's pocketed out. We removed all the excess material and made it as light as possible. The only downside of this is that this little helical feature that's in the latch is a 5-axis machining feature operation. It's actually almost arguably needs an additional axis to do it properly. It's very, very difficult. So it's achievable. We use the heads of the screws for the alignment pins right there that hold this section right here, which creates the undercut with the chamfer on the reverse side. And it also has these little rubber pads that are inset adhesive backed into a recess. So that sort of dampens it when I put it together. So there we go. Cool. Thank you, Chris. So when I rotate this, you'll see the head of it. I'll try to hold it up here to the camera. You see the head of it draws in. I pop it, and you see there's a nice little snap. So this is a really cool little mechanism we have a patent on. And we're perfectly happy to share it with you guys to use it on your project here. So another one I'm going to show you that we invented here, this is another cam mechanism. And it's a really cool, simple mechanism. And the way it works is you'll notice when I turn this red lever right here, it's going to draw that plunger in, okay? And when it's out, one of the really cool things about it is it's spring-loaded. So this works like a seat belt buckle. In fact, it works similarly to how a racing seat belt, like a say belt, works in a race car, where you actually have a twist cam on the thing. So when you pop it all together and you pop all your 6-point harness straps together into the individual lock in the middle, you have one single center lock. Basically, what they do is they have a ramped feature that's sort of like a striker on a door. So they actually chamfer the end of the spring-loaded pin, just like when you close a regular door in an office, and it depresses the pin, and as soon as it goes over the center just enough and clears it, of course, and the clearance design, the tolerancing of the parts is very, very critical to pull that off. That plunger pops right back out into a groove and it locks it in place, just like a regular seatbelt, car seatbelt does. And you know, it's a tried and proven ancient design at this point that you really can't go wrong with. So if you're able to put enough force on the wings together, you can do a mechanism like that where it just locks. And then in order to release it, all you have to do is have a cam lever of some sort that you just rotate, and this is only a quarter turn, as you can see. It's a very, very short 90-degree turn, and boom, it disengages. And then the wings come apart. So that's another mechanism that can be miniaturized. You know, the nice thing about this is it can be made very small. It can be made even smaller than it is now. You can ramp it like a striker, like I say. But, you know, the devil's going to be in the details on the tolerancing and the clearances in that part, getting it just right. So it's not my favorite design for your project because there's just too much that can go wrong in the design. There's too many, you're going to have a lot of stack up tolerances to deal with in your airframe, especially because a lot of your wing sections and things are likely going to be made initially, you know, hand layup like everybody does for, you know, the low cost, you know, initial run. And so you're going to have a lot of stack up tolerances to deal with, a lot of post-process machining to deal with. And that kind of a design is very reliant on, you know, as age old as it is, as tried and proven as it is, there's a lot of black magic in making that work right. It's kind of like a slide on a, you know, semi-automatic handgun. You know, there is a lot of clearancing that is baked into the design to make it work the way it does. Especially when it heats up or it's cold or whatever, it has to keep working. Even if something contracts or it's expanding or simultaneously expanding while something else is contracted, you've got to have that baked into it and really think it through. So that is a much more technical design than it sounds. Whereas a draw latch is simply, you just wind that in a little bit more and it pulls the wing harder. And you can adjust it just right so it's not inducing too much stress on the airframe. Whereas the other thing, you can force it and you could end up putting, you know, induced stresses in part of your wings that could be catastrophic. So it's not my favorite, but it's a solution. It is something to consider, and it can be made very elegantly, very small. And we've proven this is really rugged. This actually goes in a military product that is that we've done in the past, and it's just indestructible, absolutely indestructible. So it passes loose cargo testing with 150 pounds in it, to give you an idea. Loose cargo on a electrodynamic shake table. So as far as pogo pins, I'm going to show you just, these are not the only examples, but do some research on that online. There's even ones that are semi, I forgot what they call them, but they're basically a type that inserts part way. What I'm about to show you is the type. These are made by a company called Milmax, and we have used these on drones. In fact, we do use these on drones. So this right here you can see is the pogo pin side. Okay, so this side gets discrete wires. This side right here has spring pins. So I can push down on them right now and push them flush. The opposite side right here, you can see is just simply copper pads. Okay, and then the other side is again for your discrete wire solder connections. You could even get these where they're pin connections for boards, so you could just go straight to the FR4. But basically all that's happening with these, and I'll see if I could do it in the video well enough here, is these are basically just contacting. They have to be precision aligned. You can see it right now. It's basically no stress on it. And then when I push, it takes approximately 10 pounds of force to close this. Okay, so this is where a draw latch would work great. And as long as you have alignment pins to the furthest extremities of your wing rib or spar, as long as you have your pins, your guide pins to the furthest extremities and their precision, and I generally recommend doing a diamond shaped pin that's custom rather than a round pin that goes in a round hole. Do a diamond that goes into a round hole because it'll cut down on the surface area, which seems like counterintuitive, but it's actually a good thing because when you're dealing with extremes, it'll prevent the binding that you can get from a one-to-one fit. The other thing you want to do is you want to do a conical shaped pin. So the pin needs to be designed in such a way that it basically is sort of like a Morse taper fit, like what they would use on a spindle for a machining center. So that way it does release really easy, but as long as it's under the proper tension, it's basically one-to-one, but it almost falls off when you remove the latch. I believe that's going to be the answer for your design.
Alan, those pins from Milmax, do they come with a solid dry lubricant on them?
That is a good question. I don't think so. I think typically what we would just do with them is ordinarily you would make the entire circumference around the spar at the edge of the wing there O-ring sealed with like a silicone or a fluorosilicone gasket or even a Viton gasket. Those are all contenders for what you're trying to do in your environment. And then you'd seal that area and then you just put dielectric grease on the area. But no, I don't think so. But I bet they could do whatever you want. They're actually a great bunch to deal with, and they are a US based company. I think they're up in Massachusetts, if I'm not mistaken. So not too far from you guys. Any other thoughts or questions or?
Just one quick comment. I think Chris may have gotten kicked out of the meeting at one point. Chris Strange. I saw that he had left the chat and I don't see him here, but
Oh, uh-oh. Yeah, it seemed like I had lost voice from you guys. I hadn't heard anything there for a while. Yeah, hopefully we send him a text or something or.
That's okay. I think we have a recording of the meeting, so that'll be sufficient for Chris's report.
Great. So Ron, what do you think about that concept? Does that seem reasonable to you? That direction?
I like the latch issues. I do want to run some very cold temperature tests on the push pins to see if they're not going to bind under those rapid extremes in temperature.
Right. Yeah. All considerations for sure. You may have to get something more custom from them that is, has more clearance potentially. That's really it. I don't think you're going to have a lot of problems. You can do a dry lubricant for sure, on this stuff, I would imagine. I don't see why you couldn't. Only issue right now is they probably don't have the clearance for it to do like a PTFE type of coating is what you're talking about. Is that what you're thinking?
Well, it would have to, I believe it would have to be a conductive coating. So I was looking at more of a carbon type lubricant.
Okay, well, I was thinking around the outside shell parts of it, not the end pin. But
I was just worried about the pin sticking and not popping out.
Yeah. You'd probably have to work with them a bit on the clearance, maybe, but I can tell you these have been used in those extremes. So I don't, I can't really point to an example on this call that I can really talk about related to that, but we've done things that fly at 60,000 feet sometimes. So it is, not our drones, but things for other customers. I think it's all doable. And by the way, they're not the only pogo pin manufacturer. What I think you should do is look at I'll give you a manufacturer to consider that I don't know that you're familiar with, called, Chris just sent me a message saying that his internet dropped and he's just trying to reconnect now. Super sorry. So what I would do is look at ODU connectors, ODU, okay? ODU makes really, really nice electrical connectors. And in fact, we use their product on 2 different projects right now. And they've got some real super cool technologies on their connectors. They make connectors that do insert, and they're very smooth on the insertion, and they're also waterproof, and they are designed for extremes. They're beautiful connectors. They're expensive, but they're some of our favorites. So just peruse their website when you get a chance, and you'll see what I'm talking about. We use them on lithium batteries and a wide array of stuff. So ODU is definitely a consideration. I would say our next favorite connector company is Fisher Connectors, Fischer. And Fisher makes really, really high quality stuff. They're a Swiss company as well, so they're not cheap by any stretch of the imagination. They're located in Alpharetta, Georgia, and they're super helpful on their products, including doing custom products. I'll tell you my third that is absolutely my favorite for custom stuff and quick turnaround. They kill everybody at the turnaround. Nobody can touch them in all my years of business. Okay, and I've done business with Limo and Borg Warner and Glen Air and all the names that we all know in the defense circles my whole career, and none of them are good at customer service or getting you product fast in general. But Ultimate, it's just like it sounds, it's ULTI-MATE. Ultimate is awesome at quick turnaround. I mean, they have done connector projects for us that are custom, completely custom, from scratch, machined on their machining centers, assembled up and shipped to us in 48 hours. And that's just blown us away. And we're lucky if we get connectors from people who already make them in 48 days sometimes. So they're pretty phenomenal at custom connectors. So I would consider all of the ones I just mentioned. That is my learned experience from 26 years of this business. Right there. They are my top vendors for connectors, period. Milmax is awesome, but I don't know that they're going to be super appropriate, because the one problem with Milmax is because they're surface contact and they require being under a constant load because of your extreme temperatures, like you mentioned. I'm not so worried about them binding as much, Ron, as I would be worried about the expansion and contraction issues you could have with all the dissimilar materials we're talking about. These things are injection molded. You've got copper, you've got aluminum, you've got, carbon fiber with whatever matrix, probably epoxy, I would imagine. And, then you've got, titanium and aluminum coming together in some cases, possibly for the latch. So you've got a smorgasbord of potential problems there. So my favorite, I think, for you guys is going to be Odoo, or you do can connectors, cylindrical mil-spec connectors that you just pop into, or something like it. They don't have to be mil-spec, but most of them are made in Europe actually, other than like Glen Air and Ultimate. Ultimate was formerly Molex, by the way. So they had a lot of money in the beginning, and then they separated and parted ways. And some of the executives kept Ultimate or separated it somehow. But they're great people to work with, and they're out in California. I want to say in Irvine, California. But super good company. But so you could do something like that where you just have an area with a service loop, and you just plug a cable from one side to the other. It's totally waterproof. That would be a really secure way to do it, where you won't have to worry about it. But it's more work, especially since you have so many parts to this aircraft. It might take more time than you'd like. So if you want to do ones that are actually just doing a handshake when you latch the wing, then I think probably your best domestic solution is going to be the Milmax. People talk to them and see if they can do something custom that would work, and I bet you they would, just for the publicity. And then also look at Odoo, because Odoo makes absolutely killer connectors for what you're talking about. They already have them, but they're sometimes a little hard to get your hands on, and they are very expensive. They are little pieces of gold. And I think the bigger challenge is just going to be in the tolerancing, of the parts that you're going to have to deal with, Ron. I don't know that you're going to want to use necessarily carbon lubricant, because of the fact that you could end up shorting between the contacts. They're so close together. I don't think you're going to need to go that route myself, but I think you need to it will be critical on the tolerancing. And all these companies I mentioned, they're all good at that. They make jewelry. Sorry, did I lose you guys again, or?
I'm able to hear you. It's possible that there's connection issues elsewhere, but I think we're hearing you in here, and it's recorded.
Yep.
Okay, it doesn't look like we're having any luck getting Chris back on. Shoot, but he'll have it recorded. So
Yeah, this is a great start, Alan. We're still at a very early phase. We still haven't pulled the aircraft out of the constrained CAD, where we're still defining the airfoil and plan form. I know one of the concerns we have is, how do we make the connections on the back of some of these connectors in a sealed wing? So I'd like to see the connectors being part of the wing, but of course then you can't make the connection to the wires.
Yep.
So you'd envision these things as being attached via screws with some kind of embedded threaded metal inserts?
Yes. You're talking about the latch mechanism, or are we talking about the connectors again?
Both the electrical connectors and the latch mechanism.
Yeah. I've shown you some things, Ron, that I can't do on a recorded video right now. That where how we do that. Unfortunately, I can't show you the exact example of it that I think is totally appropriate to what you're asking. In fact, we even did a redesign of the mechanism that's better than ever. It's really, really neat. But I'll try to lead you to water, so to speak, on the call here. Basically, your spar on the end of your wing is going to likely want to be something like aluminum, and you're gonna nestle the connectors into counterbores and screw them into place. And you can make the aluminum. What I would recommend you do is, don't make the aluminum solid. you're going to want to poke holes in it like Swiss cheese to reduce the weight. But it is probably the right material for what you're trying to do. Okay, for just that one end piece. Doesn't mean that you can't do it still in carbon. You could, but it's going to be harder for you to do it. You're going to have to do a compression molding process if you want to do that with any relative accuracy. Now, that's something we could do. That's a pretty significant investment because you'll have to do it for all of your wing, that end cap effectively on each wing section, wherever you have the connectors and wherever you're joining the two halves. What I would likely do is either do a foam-filled wing or do one that has basically a conventional spar arrangement. If you go to the latter solution, it's far more work than a foamed wing. So you're going to have to make the individual, end caps and whatever, the few number of spars that you would end up having in a foam-based wing design. They would have to be very structural on their own, on their own. Aluminum is an easy material to work with for that. It's a little heavier and higher density than you're going to want. But what we do with it is we literally perforate it with small holes, really small holes, like, holes that are in the, 2 millimeter, range or so. And we'll put hundreds of holes in the part to lighten it up. We'll put them everywhere we could possibly do it. And the reason we do small holes is so that we keep a lot of connections and we have a lot of webbing in the part, and it remains a very rigid part rather than doing big cutouts in it. And that works really well. And it's a tried and proven design, and the whole thing gets bonded right into the wing structure. A lot of times we use tubing as well as cross members, basically through the root of the wing, one at the leading edge and one near the trailing edge. And then we'll still do foam as well. So you could do foam, you could do balsa as well. And I think you're going to want to do something like that. You're going to want to use a medium density foam, or you're going to want to do the balsa, because you're going to want this all to be relatively crush resistant, so that it can be handled in a, difficult environment, one where you're probably bundled up, one where you're probably not going to be able to, gingerly handle everything because you're freezing, right? So, you're not going to have a lot of comfort while you're doing this. So you got to think about those things when you do this design. It needs to be there's a real finite balance between making it as light as possible, so you get, you reduce your parasitic drag, of course, but you make it strong enough and durable enough that an operator in a harsh environment can, handle it without damaging something. Does that help?
It helps a lot. Yeah, thank you, Alan. And we have a recording. So why don't we just adjourn the meeting, and then we'll work with this, and we'll probably pick up again in a couple months when we're back to that next phase.
Okay. Yeah, that's fine. And like I say, we're happy to help you guys on the latch mechanism, but do a little bit of research to think about it. But I really think the draw latch is the way to go for you guys, because it's just idiot proof, and it really. It's very, very nice, especially when you're in the early stages. To do something like this, you have to have absolute precision through and through in the product that you're making. You have to be tensioning it right. You have to have the right travel. You have to have everything spot on. And you're making this for the first time. So there is nothing that's going to be spot on right out of the gate. And so having something that has maximum adjustment like that draw latch is just really cool, because even if something's a little bit off, you may not notice it in the flight characteristics at all, but you will notice it when you put the parts together. So I always like to have those kinds of things in the kind of at that early stage gate, and then you can later come back to it, revisit it, and say, hey, I'm going to pare this back, or I'm going to do something that's more feature specific to what I'm trying to do. and I'm going to reduce the weight even more. I'm going to simplify it, and I know exactly what the length needs to be, and I know it needs to be plus 3 thousandths and minus 0 or -2 or whatever on your tolerancing, and you're good. You're rocking and rolling. And you just make the same thing every single time, and you never have to worry about adjusting a screw or anything. It just drops right in, and that's where you want it to go. That's where I like all of my projects to eventually get. But that is that nirvana is very, very hard to achieve sometimes, in the early stages of a project, especially one as complicated as you're doing, where it's a blended wing body and there's a lot of things that just aren't normal in the mainstream on a good day. You're going to have problems with that stuff. So you just have to, you're doing something really cool, but you definitely have to pay homage to the fact there is black magic in all the things that we do, right? There's a lot of engineering and physics behind it, but at the end of the day, you still have to know just what to do with it to make it work right.
So I'll leave you with one of our biggest engineering challenges. The landing configuration is we have effectively 150 millimeter scooter wheels in the wingtips that are turned down, and then we have the main retractable nose gear. That's going to come down 3 points, and it's a big wing, and most of the weight is in the center.
Mm-hmm.
It's going to have to not flex down to where we're going to get tip strikes.
Sure. Yeah, that's a real challenge. Definitely. So, it brings up an interesting point. So you might want to think really creatively about your internal wing structure. Longitudinally in the wing, you're going to want to do potentially an I-beam kind of design. That may be the better way to go. And you're probably going to want to do it with carbon tape, unidirectional tape, because you're going to want as many plies going longitudinal with the wing and very little going basically perpendicular. You definitely, anything that you do, because of the long wings, you're also going to want it to be a balanced hybrid of whatever materials you're using, because if there's anything imbalanced about it because of the CTE mismatch, especially if you do more plies in one direction than the other, you could end up having warpage and tacoing with the parts. So even an epoxy-based carbon fiber. So anything you do, let's say you're going to do 10 layers of uni in one direction, longitudinal, and then you need to have some bidirectional plies. You want to do them all in the middle, or you're going to want to do them all on the, you're going to want to do half and half on the outside surfaces. You just don't want to do something where one side is one direction, the other side's the other direction, or you're going to have a lot of problems trying to get any of that warpage out of the parts. It won't work. So those are areas where you could definitely run into problems down the road, is if you do any of these asymmetric, especially at the low temperatures. This is where the matrix can fail on you, because that contraction that can occur in certain thermosets. So it's not so prolific in epoxy as it is going to be in a hybridized thermoset like vinyl ester, is an example, because that's basically a plasticized thermoset. So it's, to go from epoxy to vinyl ester, they actually take epoxy initially and they modify it, and it's done in a separate factory. It's a very complicated process, and it's highly plasticized with thermoplastics like styrene and ABS, and it gives it some inherent pliability, but that also gives it some instability at certain temperature ranges, and cold is one of them. So you're going to see more extreme in the cold than it would be even at the hot end of the spectrum with materials like that. And that may be an appropriate material, because that matrix material will give you kind of the best of both worlds. You can, it's a thermoset, and you get the high yield strength to some degree, not quite as high a degree as you do with epoxy, but you will get some pliability of the plasticizers because it'll give you a little bit of twist and flex, which could be a good thing when you're doing a landing and you're kind of belly flopping, somewhat with a lot of weight in the center and the wings are flexing a lot. It's going to flex rather than end up with micro contusions the way that epoxy might. So, so there's some inherent advantages, but it can create problems if you're doing something asymmetrical with the layup. And where I see it a lot is when people are skinning the wings. That's where they make that mistake. It's a novice mistake in the composites industry. A lot of people will sometimes they'll put glass on the inside, or they'll do unidirectional carbon on the underside of the wing, and then they'll do 2x2 on the outside of the wing, let's say. And that mismatch between the two and the induced stresses that are baked into the part when it cures and it exotherms can cause you all sorts of problems. And you'll see it right when it comes off the mold, but you're going to see it exacerbated at cold temperatures. So, so it's a very, what you're doing is extremely technical. It is not trivial. It is totally doable and achievable, and we can definitely help guide you to do it. But it's, you definitely have to think through all of those things. And yeah, and to get out that twist, you could end up, going to a more unconventional shape with the tubing is also another option. You can think about doing like hexagonal tubing. You could, there's different materials you can go with. You can consider pultrusion, which is really good on the longitudinal strength, and it's relatively cheap. So that's a good solution. And they can pultrude hexagons and any shape you want, pretty much, octagons, whatever you want to achieve what you want. And they can even infiltrate it with other materials sometimes, even conductive interfaces. You could even do electrical interfaces through it. It's pretty cool stuff. So there's only 3 good manufacturers in the world, I would say, at doing it. One's in Finland, one's in France. My buddy runs the French company. They're the best. They're called Epsilon, and he's out of Guadalajara, Mexico. He's actually French, but married, a Hispanic wife in Mexico. He's a great guy, Matthew, and so he'd be probably the guy you'd talk to about the tubing. And they do some really amazing tubing, beautiful stuff. They pretty much invented the process that everybody else copied. So they're the premier in the business, but they're not cheap, again, is a problem. Now, for what you're doing, if they can get some marketing exposure out of it to just say, hey, we're doing something good for the world, they might just do it for you. So I would definitely try to, with all of these vendors, I would definitely try to leverage what you're doing, the greater good that you're doing to get some parts. I'm sure they would, many of them are going to chip in and help you, just like us. So.
Chris, I see you're back. Do you have some closing remarks you want to make?
Yeah, I'm really sorry. My internet dropped while I was, you just finished talking about the latches and started talking about the electrical disconnects, and it dropped. So I ran over to the nearest Starbucks, and it's the only place I get internet. But I really liked the second latch you were showing us, and yeah, I have to I'll have to go back and watch the recording again. I'm really sorry.
No, don't worry about it. We understand. It's one of those new wonderful things that we're all going through because of COVID. So no worries. Understand. But yeah, we'll help you any way we can, and maybe go back through the video. And if you have any other questions, feel free to email us. Keep my other guys in the loop. I should introduce them to you just real quick, just so you know. I've got on my team here three guys. So Cooper is an engineer in training, mechanical engineer in his last year of school. He's doing an internship with us, and we've got him involved in quite a few things here, and he's really doing well. He's working like he's been at it for a while, so it's definitely a good sign. Sean is our UAS manager here. So we've developed, I want to say in all, something like 13 ground up, like really significant, crazy drones over the years, including ones that are amphibious and carry weapons. And we have one that carries a 5-round 40mm grenade launcher. So he's in charge of all that, and he's a pilot. And he's also acts as our program manager here. Stefan here is a new mechanical engineer with us. And again, he's doing great, and we figured it'd be a good learning experience for him as well. So, I've been at this a long time. And one of our main gigs here, you'll see a lot about with us, is we're really, fastidious about the details and devils in the details, like they say. And we do not leave any details to chance. So we're big on if somebody doesn't, I'm all for, if you could buy something off the shelf, that's great. But often I cannot find something that is optimized the way that I would want it if I was buying it. And if that's the case, then I just design it and I make my own. And over the years, I've been fortunate enough to build a really big robotic facility, really big capability in a robotic facility. It's not a huge facility, but it's a state-of-the-art facility. And we have 170 metric tons of robotic equipment now. So we're very fortunate for that, and we can build anything we want, pretty much. We build a lot of crazy stuff here. I still wake up every morning excited about the things that we're creating every day. We're inventing something almost every day in this facility. We're doing 2 patents just this week, and I'm on my, 170th or something like that right now. I don't even know. I've lost count. So it's a lot of fun. So the counting part's no fun, but everything else is fun. So yeah, if we can help you, we'll definitely be a good resource for you. And if you want to bounce designs off of us, I would implore you to definitely, like I say, reach out to Southco, get latches from them. They'll send you free samples a lot of times as well. Of course, they're sending them to you with the intent that you're going to use their product. And most of the time when we get them, that is exactly what happens. We do buy their product. Sometimes they do have the perfect product. Like if we're doing a transit case, let's say, I don't need a titanium latch on a transit case. Their stainless steel latches are just fine. But look at also their draw latches, the cam draw latches that they have. Those are really neat, simple mechanisms as well. They're kind of butterfly latches, and you just turn them and they draw in. They're very small, but they're heavy. They're bulky. But you could do a redesigned version that's lighter. It'd be probably a little difficult to make it really nice and clean so it sits really flush on the wing. But they are, that's one I didn't show you, but it's pretty neat, and they're used on every transit case just about in the world. They're very popular. So yeah, so that's the gist of it. And I gave you guys a lot of information, brain dump today. I think it'll at least be a good start for the conversation.
Yeah, thank you so much. This stuff you're showing us is really awesome. I'm really looking forward to working with you guys in the future.
Us too. Yeah, and thank you again, Ron, for all the help this past week. I owe you definitely. I think there's definitely some safety in numbers, as they say. So hopefully the fact that we piled it on this time with a whole bunch of partners and companies that even a university institution for support on the software and the AI and machine learning stuff, I think that's going to definitely better our chances, besides the fact the drone is really cool. So
yeah, it seems like a great project. So I'm hoping you guys are going to win this one.
Us too. Yeah. Thank you so much. We owe you.
All right. Well, thank you so much. Good seeing you. And we'll get back to you in probably about 2 months, I think.
Sounds good, guys. I appreciate it.
All right.
Take care, everybody. Bye-bye.
Take care.